Section 1.5. We're going to take a look today at variables and expressions. So a bit of vocab throughout the beginning parts here. First, variable. A variable is a symbol, usually a letter, used to represent a value that is variable, i.e. it changes, or it's not constant, it's not always the same. We see x and y used a lot in algebra. It's not the only variables we see used. If you've done anything with angles, you might have seen theta used, some of the Greek letters. You like to use theta and alpha and beta. Those are ones that are frequently used in geometry or trigonometry. And then sometimes we'll see things used like A's and B's. But there's really nothing special about any of them. They're just representing a quantity that changes. I know, it keeps flickering. It'll come back. So the first thing we're going to look at is evaluating. So evaluating actually just means letting our variable equal a specific value. So if we have an expression like this one where it's 4t minus k, and they tell us that t is, sorry, let me change that color. They tell us t is 2 and k is negative 3. Evaluating just means that we are going to substitute those values into our expression. So we have a 4, and then our t is 2 minus, and then our k is negative 3. Parentheses often help to distinguish what you're evaluating into so that you don't end up with some weird sign things going on. If you're not careful, you might end up making something that's really multiplication look like addition or subtraction if you're not paying attention. So I think parentheses are often quite helpful. So what we want to remember is that we always multiply before we would add or subtract. So as we're doing this particular problem, we'll do the multiplication of 4 times 2 first. And then what happens when we subtract a negative? Do y'all remember? So it's addition. So I have 8 plus 3, which yields 11. Yeah. So our evaluation value is 11. We can do the same thing whether we have a linear expression, which the first one was, or something that's not linear. This next one's not linear because it's got a squared in it. It does only have one variable, though, and they tell us that variable value for this problem is negative 4. So in place of the a's, I'm going to put negative 4s, again with those parentheses every time I see an a. So order of operations, mentioned it briefly before, that we need to multiply before we add or subtract. We also need to do exponents before we multiply. So now we see an exponent here. That's our first step. We will first need to do the negative 4 squared. So the 3 is going to stay, and what is negative 4 squared? 16. It's 16. On the next part, if you want to go ahead and do the multiplication, you can. I'm just going to save the multiplication for all in the same step, so I'm going to wait on it for a moment. 3 times 16. Do you know what it is?
48.
It is 48. Good job. 48. If you don't know, grab a calculator, right? We have a negative 2 and a negative 4 here. So when we multiply the negative 2 and the negative 4, we get positive 8. Right, negative times a negative is a positive. And then plus 4. So I have 48 plus 8 plus 4. And what will that yield? Somebody said it. Yeah, 60. So we're going to do a few problems where you're going to practice evaluating. Yeah, Haven.
So, I broke the rules with exponents, but I put the squared inside the parentheses. It doesn't matter if it's inside or outside.
It actually does, and more in particular, it matters because if you try to verify with your calculator will not do it with the order of operations properly. So anytime you're evaluating into something, make sure it's only that value going inside the parentheses and everything else happening outside the parentheses. We want to be a little bit careful in particular with negatives. They're the ones that cause us trouble because we want to make sure we recognize that it's the negative 4 in this case that's being squared, not just the 4 and then putting the negative on afterwards. And your calculator can misinterpret that if you're using it as a check step or whatever, and then you're left going, well, what did I do wrong? And actually maybe it didn't. It's just your calculator didn't know what you meant.
Thank you.
All right, so on our next slide, we're going to get a little bit more vocabulary that's kind of a pet peeve in mathematics, and people do this all the time. is that they say they've got an equation when they really have an expression. So an expression is a mathematical statement using numbers, variables, and operations. An equation is a statement of equality. In other words, it has an equals sign between two expressions. So these over here, we did not have equations, we had expressions. This, sorry, not that, is an expression, and this is an expression because there are a combination of letters, numbers, and operations with no equal sign attached. In particular, you can evaluate expressions like what we just did. I'll flip back to it, I promise. You can evaluate expressions like what we just did, but you can't solve them. Solving has to do with finding out what a value actually equals, right? What one of our variables actually equals. So when we are solving, we're actually mathematically or algebraically manipulating an equation to isolate a single variable on one side. Okay, so what we did before is called evaluating, and we evaluate expressions. What we're about to do is solving, and we're going to solve equations. Now, solving equations doesn't necessarily mean we get the variable equal to a number. It's just equal to something that it's being expressed in terms of. So the first example that you see here, we're not going to find out what it is that z is equal to in a numerical form. But we're still doing what it says over here for solving. We're isolating the variable it's requesting on one side and removing everything else to the other side. Okay? So we have on this one x minus y minus z equals 7. I'll put in a service request for this. The blinking is very strong today, isn't it? All right. So as we're taking a look at this, I need the z alone, and I need everything else to move. So you have a couple of options. You can either move the z to the other side, which will make it positive, and move the 7 this way. Or we can move the x and the y, and then we can make the z positive by multiplying or dividing by negative. Either way we do it, we have a two-step process. It doesn't really change how long it's going to take us. So I'm going to leave the z where it is and move the x and the y, but if you prefer to do it differently, that's okay. So I need my x to move to the other side. Right now, the x is understood to be a positive in front of it, right? Because there's not a sign. So the opposite of that would be to subtract an x. The y has a negative sign in front of it, so the opposite thing to do there is to add a y. So as I'm thinking about what I have here now, these two add to 0 and these two add to 0, which is the whole point. We don't want anything on this side except for z. Now at the moment I still have the negative in front of the z. I'll have to deal with that as a second step. But what I have now is a combination of these pieces all written side by side because they can't combine. 7 minus x plus y. Okay, so far so good? Okay. Now I still need to move the negative. You can think of it as multiplication or you can think of it as division. I think visually it looks a little bit clearer to think about it as multiplication, so that's how I'm going to write it. And if I multiply on the left side by -1, I have to compensate by multiplying on the right side by -1. Now again, the whole point in doing that is that I now have on the left side a negative times a negative, so I have a positive z. And then on the right-hand side, I need to distribute this negative to each individual piece. And in particular, what that means is all my signs change, right? So instead of a 7, I now have a -7. Instead of subtracting an x, I have addition of x. Instead of adding a y, I have a subtraction of y. And there's other forms that we could have this written in. Right? I could manipulate the right-hand side so that it says x minus 7 minus y if I want to. That's fine. It doesn't help anything. But there's other ways that it could be written in the end and still be equal to this expression on the right-hand side. So this equation is now solved for z. Okay, so solving does not mean getting a numerical value. It simply means isolating the variable, which we did. So we have the same kind of thing happening on number 4. Do you recognize that equation? It is the area of a triangle. Very good. So my goal is to get h alone. So I'm going to just work from the far side in. In other words, I'm going to take a look first at this 1/2. How do I eliminate the 1/2 on the right-hand side? How do I shift that to be on the other side? Yeah, so we can divide by 1/2, but that looks a little bit messy. There's a different way we could do it so that it doesn't look as messy. Right, you're right. So we could multiply by 2. So dividing by 1/2 is the same as multiplying by 2 because they are reciprocals. So if you divide by 1/2, you're just going to have more simplification to do at the end. So we're going to multiply by 2. So now I have 2a equals bh. The goal is to get h alone. So what's the other thing that I would need to do? Right, I would need to divide by the b. So the b divided by b here canceled, much like my 2 times my 1/2 canceled. You can leave this written in the form that it is. H on the right equals 2a over b on the left. If it bothers you, you can rewrite it in the order where the h is on the left and the 2a over b is on the right. Makes no difference. So why? Why do we have or need expressions, equations involving variables? What's the point? So I'd like to give you sort of a verbal description of what's the point, and I'm going to write it while you write it as well. So equations and expressions allow us to take a more complex real world, or not A, take more complex real world, that A is not supposed to be there, I don't know why it's there. There we go. Take more complex real world situations and give order and clarity using the structure of mathematics. They allow us to find solutions in an orderly way. So you don't get all those benefits immediately, right? You have to build up to being able to use algebra to do that. But to give you just a real quick real-world example of something that happened is when I was a grad student and I was teaching in Kansas, I had a student come up and tell me that they had used algebra and some of the structure that we had been learning to try and figure out what made sense to do to charge for rent in a house that they were renting with a group of students. So it was several people living in the same house. Some of them had access to using the garage. Some of them didn't. Some of them had access to their own bathroom. Others had to share. Those kinds of issues. And they had to decide what made sense equitably in terms of the cost that they were paying. Because if you've got a spot in the garage, Clearly, that's a benefit to having to park outside, especially in Kansas when it snows, right? So they had to make sense of a kind of a complex situation in a way that would make sense in terms of coming up with a solution for what their rent each individually should be. So this allows us to do that as we build up to it. So what we're going to do first, I already wrote that out, is we're going to take a look at some examples of converting language into the structure of mathematics. So we're going to encounter some pretty simple ones today. Obviously, they get more complex, but they just build on one another. And we're going to talk about these things a piece at a time. So we've got Junior. Junior has 6 brothers. Y of his brothers went to church. It says, write an expression for the number who skipped. Okay, so an expression means that it's going to have numbers and variables combined with operations and no equal signs. That's what we're shooting for here. So what is an expression that could be used for his number of brothers who skipped church? Say it again.
6 minus 1.
Yeah. 6 is his number of brothers minus y, the ones who skipped church.
When you are writing these, so do you put it in order as the numbers come?
It kind of depends on the structure of the language. So you'll see one here in a minute where it doesn't quite work that way. This one did. But it's because of the way we speak our English that it doesn't always work that way. So these 3 here don't have quite as much context, but I wanted you to get a feel for kind of what you're hitting at, Caden. Because the pattern, like the order, moving from left to right, doesn't always match the order when we write the math down. For example, it says translate into algebraic expressions. On number 4, it says 4 less than k. So the structure of the words actually flip it around because it has to be less than something, right? To be 4 less than means you're taking 4 away from something. Well, it's 4 less than k, so you're taking the 4 away from k. So you can't always just go, hey, look, it says 4. I'm going to write the 4 first. It doesn't always start that way. The product, what does product mean? Yeah, it means multiplication. I have a son in 7th grade who still struggles with those words and what they connect to. So he doesn't call them addition and subtraction. He calls them pluses and minuses. I'm plussing things. I'm minusing things. I'm sure that there's a teacher along the way that's how they did it in their classroom, so that's what sticks in his mind. So if you have some of these where they don't remind you very quickly, you're going to learn them again. Product means multiplication. So it says we want to do the product of x and 5. So you can write that in a couple of ways. What could you write? Yep, that's one option. Any other thoughts?
In parentheses.
What would you put in parentheses?
Both of them.
You could. So you could represent it like this. Yeah, that'll be fine.
More than x and the 5 in front.
Yep, you could put the x first and you could put the 5 first. 5 second.
Do you
Okay,
have
so
to
it's
put
the product of both.
Around the x on the outside, or could you do x and then parentheses around the 5?
You could do either one. You also could use symbols that are not or parentheses. You could use the dot symbol for multiplication. Please don't use the x symbol for multiplication because we're using x as a variable here. That's going to look really bad if we try to do that, okay? So you could do something like a 5.x or an x.5. Okay, if you need to use that notation. Any of those are fine. They all mean the same thing. So pick whichever one's your favorite. C's got more going on. It says 14 more than twice a number. So this 14 more than is much like this 4 less than. It actually means that we're adding 14 to something, right? So we're adding 14 to what? 2x, or if you don't want to use x, use another variable, right? Use n for number. Sometimes people like that one, or a. There are some values, like some letters, that are not good to use. Don't use s's. S's are terrible, unless they actually give it to you in the problem, of course. S's are bad because they will look like some people's 5s. T's are bad because they look like addition, right? They look like the plus sign that we sometimes use too. And of course, we want to be careful not using our symbol x for multiplication, as we will use x for variables quite frequently. So 2x plus 14. Now, it's kind of valuable to notice that this one actually, if you had started with the 14, you'd be okay. 14 plus 2x would actually work here. Why would that work here? But when we did the one that said 4 less than, whatever, 4 less than k, I was so specific.
Because it's subtraction.
Yeah, it was subtraction. So addition has this property called commutative that allows us to do it in either order, and it's the same thing. Subtraction doesn't have that property. So it's probably better in general to get into the habit of seeing that the 14 more than or the 14 less than means we added onto it or subtracted onto the end. But if on this one you did the 14 plus the 2x, you'd be okay. Any questions? Alrighty.